Okay, we're going to start the recording now then. Okay, so from there, we factored everything out. We canceled what we can, and we write what's left. Pretty much how that works, whatever's left over. So moving on to the next example, same exact approach. We're going to go in here and we're going to start by factoring out whatever we can. So on top here, we have a GCF that can be taken out. Those both contain a factor of 2x. So we factor out 2x, which leaves 3x plus 4 on the inside. On the bottom, we have basic trinomial factoring, a equal to 1. So we're looking for numbers that multiply to -10 and add to -3. That would be -5 and +2. So that factors into x minus 5 and x plus 2. On top, this doesn't factor. So we just leave it alone. All we're going to do is put it in parentheses. So x plus 2 stays the same. And then on the bottom, that doesn't factor either. So all we do is put it in parentheses, 3x plus 4. Now that everything is factored, we're going to go in and cancel anything that we can cancel, which would be the 3x plus 4s, those would cancel. And the x plus 2s, those would cancel. Nothing else there can be canceled, so our final answer would be 2x on top and x minus 5 on the bottom. So once again, it's very, very, very important that we are able to factor and factor completely and factor in all of our various ways. So we have to be fluent in factoring to do this lesson. Okay, so now we're going to talk about division. And we're going to do it the same way. We're going to consider a much simpler elementary to middle school level problem. That is 15 halves divided by 3 halves. You should remember that what you're supposed to do here is called keep, change, flip. Now what I mean by that is that we keep the first fraction the same. We change division to multiplication. And then we flip the second fraction to be 2/3. From there, we should go in and cancel whatever common factors we can, for instance, 2 and 2. And we should know that 3 goes into 15 5 times. Then we would multiply straight across, which would give us 5 over 1. That would be 5. So those are going to be the same steps we take with polynomial fractions. We're going to keep, change, flip first, which means we're going to change a division problem into a multiplication problem and flip the second fraction. We leave the first fraction alone, change division to multiplication, and then flip the second fraction over. We'll then factor everything, cancel whatever we can, and then multiply straight across for whatever's left, just like we did with multiplication. So division is exactly the same as multiplication, except there's a couple of steps added to the beginning, by which I mean keep, change, flip. Okay? So here we have a polynomial division problem. So what we're going to do, we're going to start by doing keep, change, flip, which means we're going to leave the first fraction completely alone. We're going to change division to multiplication, and then we're going to flip the second fraction over. And now it's a multiplication problem instead of a division problem. So that's our first step, is keep, change, flip to turn it from division into multiplication. Now we're going to go in and factor everything. So our first trinomial here is just a basic trinomial with a equal to 1. Which means we're looking for two factors that multiply to 9 and add to 6. That would be x plus 3 and x plus 3. And yes, you may write that as x plus 3 quantity squared if you like. The bottom cannot be factored, so we just leave it alone, x plus 2. The top of the second fraction now cannot be factored, so we leave it alone. And then the bottom, x squared minus 9, that is a difference of 2 squares. So that will factor into x plus 3 and x minus 3. Now that everything is factored, we go in and we cancel whatever we can. So we can cancel the x plus 2's, and we can cancel a x plus 3, but only one, because there's only one x plus 3 on the bottom. From there, we would simply multiply across whatever's left. So on top, we still have an x cubed, and we still have an x plus 3. And on the bottom, all we have left is an x minus 3. So our answer would be x plus 3 times the quantity x cubed times the quantity x plus 3 over x minus 3. And we're done. That problem is complete. We can't do any better than that. So on to the next one. This one, everything's trinomials here, so there's lots of trinomial factoring, but first we need to do keep, change, flip. So we keep the first fraction exactly the same. Change division into multiplication, and flip the second fraction over, x squared minus 9x plus 18 over x squared minus 2x minus 15. All right, now we're going to factor everything. So our top of our first fraction, we're looking for two numbers that multiply to negative 15 and add to positive 2. Again, that's multiply to negative 15 and add to positive 2. That would be x plus 5 and x minus 3. On the bottom, we have x squared minus 3x minus 18. So we're looking for two numbers that multiply to negative 18 and add to negative 3. So that would be x minus 6 and x plus 3. On the top of the second fraction, we currently have x squared minus 9x plus 18. So we need two numbers that multiply to 18 and add to negative 9. That would be x minus 3 and x minus 6. And finally, on the bottom of the second fraction, we need two numbers that multiply to negative 15 and add to negative 2. That would be x minus 5 and x plus 3. Once everything is factored, we go in here and we remove any common factors from top to bottom. So we can cancel the x minus 3. Oh, I lied. No, we can't. Let's try that again. We can cancel the x minus 6's. And that is it. Nothing else there will cancel. So we write what's left. Nothing else there will cancel. So we write whatever's left over. We have x plus 5 times x minus 3 times x minus 3 over x plus 3 times x minus 5 times x plus 3. Now you could write that as x plus 5 times the quantity x minus 3 squared, because that's the same binomial factor twice, so it can be written with exponents, over x plus 3 quantity squared times x minus 5. That's assuming, of course, that I haven't screwed up anything anywhere, but as I look at it, I don't obviously see any screw ups, so I'm pretty sure that I've done that correctly. So one of these two would be our final answer. It doesn't matter to me which one you give. Your pre-calculus teachers next year would probably prefer the second one, but there's really no difference between the two. So that one was a little bit more work than the one before it, and they vary these problems vary in the amount of work and the amount of effort they take. So what I want to do is I want to show you one more example that is about as hard as they're ever going to be for you here in Algebra 2. And then we will be done for the day, and you guys will be able to take off probably about 20 minutes earlier than normal. So here we go. This is as hard as these problems ever get. Some of these have several steps of factoring in them. It's a division problem, so we do need to start with keep, change, flip. And we actually have a not equal to 1 factoring in there. We've got, which requires factoring by grouping. There's just a lot of different kinds of factoring. So this is like as hard as these problems would ever be for you in Algebra 2. So we start off, we do keep, change, flip. So we have 2x squared plus 4x minus 30 over 2x squared plus 5x plus 2. In other words, we keep the first fraction. We're going to change division into multiplication. And then we are going to flip the second fraction over to 2x squared plus 3x plus 1 over 4x cubed minus 4x. Now we are going to factor. So we have to factor each of these as completely as possible. So the first thing we can do is we can take a GCF of 2 out of this top fraction, which would turn it into 2 times the quantity x squared plus 2x minus 15. And then that trinomial will factor again, because there are numbers that multiply to negative 15 and add to positive 2. They are positive 5 and negative 3. On the bottom of that fraction, we have an a not equal to 1. So remember that we're looking for numbers that multiply to 2 times 2, which would be 4, and add to 5. That would be 4 and 1. And then that means we're splitting up that middle term into a 4x and an x, and then we're going to carry out factor by grouping. So that first set of parentheses, we can take out a 2x, which would leave x plus 2. And the second set of parentheses, all we can do is leave it alone, take out a 1. So my factors would be x plus 2 and 2x plus 1. Okay. The top, this is also factored by grouping, because a is not equal to 1. So we'll write that down here in the open space, and we'll factor it out down here because there's no room to do it up above. 2 times 1 is 2. I need numbers that multiply to 2 and add to 3. It's 2 and 1. So we break up that middle term into a 2x and a 1x. We group and we factor. And again, we've done these dozens of times this year. So hopefully it's at least looking somewhat familiar to you as far as the factoring goes. We would factor out the greatest common factors from each set of parentheses. The first set, there's a 2x we can take out. The second set is only a 1. And then the factors would be x plus 1 and 2x plus 1. So that's the top of our second fraction, is x plus 1 and 2x plus 1. See if I can make that fit any better. Ugh, not really, can I? Okay, we're just going to move this whole step down below. So we had 2 times x plus 5 times x minus 3 over x plus 2 times 2x plus 1 And we just established that the top of that fraction multiplies into x plus 1 times 2x plus 1. And then finally on the bottom there, we've got a GCF that we can take out, which would leave us with 4x squared times x squared minus 1. And then x squared minus 1 factors again because it is a difference of two perfect squares. So it would factor into, the 4x would still be there, and then the x squared minus 1 would factor into x plus 1 and x minus 1. So the factoring is the hard part. We got to get everything factored completely. Once everything is factored completely, the problem should be easy from that point forward. Unfortunately, some of us are still struggling with factoring, so this is not going to be a super easy lesson for everybody, okay? So we look at what's there and we cancel anything that exists on both the top and the bottom. So for instance, we have on both the top and the bottom an x plus 1, so we cancel those. We have a 2x plus 1, so we cancel those. And then the other thing we can do is we have a 2 on top and a 4 on the bottom. 2 and 4 are both divisible by 2. So this 2 will go away and this 4 will become a 2. Nothing else there can be canceled. So now we multiply across with what's left. We have there x plus 5 and x minus 3 on top. And on the bottom, we have 2 times x plus 2 times x minus 1. Notice there are no common factors between the bottom and the top. So this is the final answer to the problem. Okay, folks, so that does it for the video notes. I'm going to be posting the Quiz assignment on Google Classroom. I will also post this video as soon as it finishes converting and I can get it uploaded onto Google Classroom. I'm sorry, up onto YouTube so I can share it onto Google Classroom. So you will have access to this video. Again, for whatever reason, it didn't start recording right away. So the very beginning of these notes is not on there. I will go ahead and repeat that stuff real quick, and that is that we're talking about polynomial fractions in this unit, multiplying and dividing. We basically treat them like any other multiplication and division problem. We're going to cancel common factors from top and the bottom. So when we multiply, we'll factor everything completely. We will cancel any common factors, and then we will multiply straight across. So on that first problem, we had this problem here. First, we could do difference of two squares on top, GCF on the bottom, GCF on the top of the second fraction, and the third, or the bottom of the second fraction was a trinomial. Factored everything. The green lines indicate canceling, and then we just multiply straight across for what's left. That's what we do every time, people. That's what we do every time. So it's very factoring heavy. That's all I have for you today. Thank you for attending the Zoom session. Hopefully we can get the chat thing figured out before Thursday, and you guys will be able to interact with me a little bit more on the actual class Zoom than just sitting here and watching me talk. Thank you again for coming. Remember, your screen name will need to be your first and last name in order to get into these meetings in the future. Thank you for your time. You may go. I will post the homework on Google Classroom very shortly.